Hi, my name is Greta Flores, and today I'm going to explain to you the second question from the first partial lab. This question asks for you to find where the vertical asymptote of this function is located. So the first thing you're going to do to make everything simpler in the future is going to be simplify. So what we're going to do is factorize the numerator and denominator. It's going to be the top numerator is going to be 4x plus 3, pretty simple. And then the factorization for this, we're going to use the difference of 5x in order for us to actually factorize this function. 2x squared plus 6x minus x, that's going to be a difference of 5, and then minus 3. From here we can factorize, and are gonna be left with the following. Once we simplify the function, it's going to be much easier for us to find the vertical asymptote. So in order to actually find the vertical asymptote, we need to find the x values in which the denominator would be equal to 0. So we make the denominator equal to 0, which is 2x minus 1 equals to 0, and then from there we find x. And in this case, we're going to have x equals to 1 over 2. And that is going to be our vertical asymptote, which in the partial lab is found as answer letter A. So after we factorize the denominator, we are left with 2x minus 1 and x plus 3. So here we have a chance to cancel out x plus 3. And we're going to be left with 4 over 2x minus 1. From here, we're going to find the vertical asymptote.
Okay, I will be explaining how to determine if a function is continuous or not based on a set of rules. The rules for continuity are very simple. For this, let's say x equals c. Step 1 is to check that f of c is not undefined. This basically means that you should get a specific answer. Step 2 is to check that the limit of f of x when x tends to c exists. So basically what you want is to get both the positive and the negative side of c and check if they correlate and if they're the same. And then step 3 is when f of c equals the limit of f of x when x tends to c. So if any of these steps are not correct, so let's say your first one is undefined, that immediately means that you don't need to do anything else, because if you are doing it correctly and it is undefined, that gives you your answer of it being not continuous. If we were to solve the problem f of x equals 4 over x plus 3 when x equals negative 3, first you need to check on step 1 if it is undefined or not. That means you just plug in the negative 3, so 4 over negative 3 plus 3 equals 4 over 0, which is undefined. So you don't need to do anything else. You know that this is not continuous.
Hi, my name is Catherine, and I will be explaining problem number 74 of the first partial lab that has to do with the rules of differentiation. Problem number 74 of the lab asks us to find the differentiation of the function h of x is equal to the square root of 4x plus x squared. Now, what are the rules of differentiation? Now, here we can see two formulas with x and n. X being the number times x and n being the power. Now, how do we plug it in? Here we have 8x cubed. Now, 8x being x and the 3 being n, aka the power. If we plug it in, it would be 3 times 8x to the power of 3 minus 1. If we simplify, it would give us 24x cubed. Now, what happens if we don't have a power? Well, we always do. This is x to the power of 1. We plug it in as normally, and it only gives us 5. And what happens if we have a number in an equation that has no x? Well, we would just go ahead and cross it out. Okay, so now let's get to the problem. First, we need to get rid of the square root. Now, we know the square root of 4 is 2. The square root of x is x to the power of 1/2 plus, and the square root of x squared is x. Now, we just plug it into the formula we already know, which should give us 1/2 times 2 x 1 to the power of 1/2 minus 1 plus 1 times 1 x 1 minus 1, because even though the x is alone, we always have a 1 here and a 1 here. Remember that. Now we solve, which should give us 1 times x to the power of negative 1/2 plus 1. Now the problem with this is that we cannot have a negative exponent. So we bring it down and we make it positive. So 1 over x 1/2 plus 1. Now the problem with this is that we cannot have a fraction down here. So we modify it once again, and it's 1 over square root of 2 here of x plus 1. And now we put it in our answer in the correct way, which is h prime of x is equal to 1 over the square root of a 2 here, x plus 1, and that is our final answer of differentiation.